Don't you? I feel like we should have like an opening. The Simpsons. Okay, I'm just kidding. All right, so let's move into nuclear energy. Nuclear energy, as we talked about in the first mini lecture, is technically considered to be a non-renewable resource because there is a finite amount of that fuel source out there, which most of our fission plants that we use is uranium-235. I'm a fan of nuclear. I think it's awesome. That's my bias, right? Now, let's talk about the science of it. So, nuclear reactors, what they do is they use fission to generate electricity. So, you take uranium 235, and if you've had chemistry, you may know this. And if you're in chemistry now, I don't know if you've gotten there yet or not. So, they take uranium 235, which is the mass of it, and this is a radioactive isotope of uranium. And what happens in fission is basically is they take a neutron, they throw a neutron at it, and it splits it apart. And that splitting apart releases huge amounts of energy. And as well as it creates what we call a chain reaction. So it's like boom, 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 and it just keeps going. And they can control it under certain circumstances, more so with fission than fusion. But it's a really, really highly productive source of energy, and it's pretty cool. It produces tons and tons and tons of heat, and what happens is as that heat is produced, it boils water. That water is then used to turn a turbine, and that turns a generator, creating electricity. Ta-da! All right, so here's a picture of what happens in fission. So as I was saying, they take a neutron. That neutron's like shot at uranium-235, and this is the nucleus of it. It splits apart into different smaller atoms, and that then creates that chain reaction as what you see here. Okay, and it's this part of it is basic chemistry. It can get pretty complicated, but still cool. Okay, so nuclear reactors in fission, we have fuel rods and we have control rods. Fuel rods is where the fuel is actually stored, right? Obviously, fuel rod. Now, the control rod is an interesting thing where they take these and it absorbs excess neutrons, and this is what they use to kind of help control that reaction and the rate of reaction. So the control rods also become highly radioactive, and so it's not something you just want to go in there and pick up with your hands by any means. Okay, no. If you've ever seen the Chernobyl series on HBO, yeah, it's ugly. Okay, it's ugly. Nuclear energy advantages. Whenever you drive by or you see a picture of a nuclear energy plant and you see like that big thing that comes, the big concrete thing that comes up in that what looks like smoke coming out into the atmosphere. It's not smoke, it's just pure water vapor. Because remember, it heats the water, right? And that's just hot steam coming out. That's all that is. There's no carbon dioxide in that, none of that. Right? So that's one of the advantages, is that it does not create air pollution. And once that nuclear power plant is built, it's pretty cheap. It's that upfront cost, that capital that's required to build that power plant. But once it's up and going, it's not really that expensive to maintain. Now, here's the bad part. Yes, there is a possibility of accidents. The biggest problems are, how do we dispose of that radioactive waste? And how can we make sure that the people that are in charge are doing it properly and, are not misusing it, anything like that? So whenever we get that radioactive waste, it's whenever the fuel has been depleted and whatever's left over in those control rods. So if it cannot be used in that nuclear power plant anymore, doesn't mean it's still not radioactive. Oh, trust me, it is. Now, they do have some newer technology in some nuclear power plants that can actually use some of this spent fuel and turn it into fuel and energy. So that's one possibility where you can go with this. But there's other things as well. So there's a becquerel, that's how you pronounce it. It's the unit that we use to help kind of measure radioactive decay. And a curie, named after Marie Curie, is a unit to measure radiation. And so they monitor this very closely. And if you work in a nuclear power plant, they monitor you very closely as well to make sure that you're not becoming exposed to too much. So those used fuel rods, they have to do something with them. Okay. And then there's also things that are in the area that can also be contaminated that you don't necessarily just want to throw in the trash. Okay. So in all of these cases, and also too, whenever they go mine for that uranium, there's going to be some scraps left over there too. Okay. So there's radioactive waste that comes from different parts. What do we do with these? Well, that's the problem. A lot of times it's buried deep underground in concrete casings. Sometimes it's near the nuclear power plant. Some places there are like out in the middle of nowhere. They'll truck it out there and bury it underground because it's not near people. There's different ways and means. I remember when I was little, I used to think like, why don't they just shoot it in space? But that could be bad too. You don't want a nuclear explosion whenever it takes off. All right. So that's fission. That's how we get our energy. Fusion is super cool. Fusion is what happens in the stars, right? That's whenever you take, in fission, you take particle and you bust it apart. In fusion, you fuse two smaller particles and make them into one bigger particle. So in fusion, you can also create huge amounts of energy. It's very promising, but here's the thing. How do you basically create a star, right? Fusion, on Earth in a controlled environment in a safe situation? So scientists have been working on this. And cool fact, in Korea, they're working on this in Korea in a really cool lab, and they were able to do it, I think it was for like 10 or 20 seconds. And then they shut it down. So they're working on it. It's not impossible. It's just technically very difficult. So in your book, you will see that you have this table, and it's going to compare all of the different non-renewable energy fuels. It's also going to talk about basically what it costs per kilowatt hour, the pros and the cons, the energy return on investment. So this is something you need to kind of look at and know. You don't need to be able to regurgitate it, but you need to kind of understand, obviously, the pros and the cons, what greenhouse gases it produces, and all that kind of stuff. All right. That's chapter 12.